Routing packets across a network is a lot like a relay race. But if you drop a completely blank router onto your network, it can't run its leg. It just sits there. It has to be explicitly configured before it can participate. This diagram shows our goal, transforming a blank router, like R1 here, into a device bridging our local network with the WAN. We'll hit 4 milestones to get there: locking down security, activating dual stack interfaces, verifying routing tables, and setting up remote switch management. If you are following along on your own equipment, make sure you have an active console connection directly to the router and your IP addressing scheme mapped out. Completing these foundational steps is the mandatory baseline. Without this setup, no external communication or advanced networking is possible. In global configuration mode, we assign a recognizable name using the hostname command. Notice the prompt updates to R1. Next, we secure privileged exec mode by typing enable secret followed by our password. This is an important distinction. Always use enable secret, not the older enable password command. As we can see here, enable password leaves your text completely readable, while enable secret uses a strong hashed encryption. To secure local access, we enter line console 0, set our password, and apply the login command. We handle remote access similarly. Select virtual terminal lines with line VTY04, set the password, require a login, and allow SSH or Telnet. By locking down both the physical console and the virtual terminal lines right out of the gate, we protect the device's configuration from both local unauthorized users and external network threats. This terminal view shows the next step. We obscure plain text passwords by running service password-encryption. Next, typing banner MOTD lets us display a legal warning. This establishes boundaries for anyone attempting to access the device. Finally, we type copy running config startup config. The OK confirms our changes are stored safely in NVRAM. Do not skip this step. Without it, a simple power failure or reboot will instantly wipe out all the foundational security work we just completed. Our router is now secure, but it is completely isolated. End devices cannot reach it until its physical interfaces are specifically configured and turned on. Looking at the configuration summary, we enter interface configuration mode for Gigabit Ethernet 0/0/0. We apply a description, which saves time when troubleshooting later. Next, we assign an IPv4 address and subnet mask, followed by the IPv6 address and prefix, establishing a dual stack interface. Then comes the mandatory step, typing no shutdown. Watch the output. This syslog message confirms the port is physically awake. The test Cisco interfaces are disabled by default for security. Explicitly bringing them up with no shutdown is the only way to allow traffic to flow in or out. This output shows how we verify our work. By typing show IP interface brief, we get a fast status check across every port simultaneously. We want to see up in both the status and protocol columns. Now look at the routing tables below. We use the show IP route and show IPv6 route commands to confirm the router has successfully identified its directly connected networks. Notice the specific letters next to the IPs. The C stands for connected, meaning the network is directly attached. The L stands for local, pointing to the router's exact IP address. Seeing up and up statuses alongside C and L route codes proves the router is actively participating and ready to process incoming packets. Now we need to make sure our end devices know how to use this router. A host only requires a default gateway when communicating outside of its own local subnet. If a PC sends a packet to a neighbor on the same switch, the traffic stays local. But when that PC needs to reach a different network, it sends the packet directly to its assigned default gateway. This remote management diagram shows Layer 2 switches also require a default gateway. If an administrator tries to SSH into a local switch, it needs a path back. To provide it, we configure IP default gateway followed by the router's IP address. Setting this gateway ensures remote administrators will successfully receive reply packets from their management sessions, preventing network blind spots where a device is running but totally unreachable from the outside. Let's review our checklist. We established the device identity, locked down all access points, physically activated the dual stack interfaces, verified the routing tables, and configured our management gateways. Our once blank piece of hardware is now officially secure, fully visible on the network, and actively routing traffic. Achieving this verified baseline is the mandatory prerequisite. With the foundation set, we are fully prepared to start configuring static routing and dynamic protocols in the next step of our network build.